Hey everyone, I'm Vito Chin. I'm going to talk about the importance of creating a cloud environment that is well architected for applications. So let me start by introducing myself. I'm a senior cloud solution architect at Microsoft. I've been here for almost 6 years, and my focus area is digital and application innovation. I've been a programmer for 27 years, started from C to Java to PHP to Objective-C to Node.js. You can find me on Twitter at VITOC. Now, at Microsoft, our mission is to empower every person and every organization on the planet to achieve more. Now, when we talk about well architected for applications, we are really talking about the workloads. How do we do this well in a way that creates business value? So the business value of web for applications comes from avoiding unnecessary expenses. It comes from retaining customer trust. And it comes from avoiding damages to your business reputation. So these are achieved by managing your budget well, by improving the security of your workloads, by increasing the efficiency of your incident response, by streamlining your internal processes, by finding costly mistakes, and by enhancing the workload's performance. The Azure well-architected framework helps you build and manage high-performing workloads with confidence. From an application perspective, let's take a look at this framework. We'll start with the Azure well-architected review. So this review provides you with the gap analysis that you can use to identify area where you can focus your optimization efforts. Next, let's take a look at reference architecture. So the reference architectures in the framework helps you build and deploy any kind of workload to scale and meet your business needs. Then let's move on to the design principles. So the design principles are based on proven practices and design patterns from successful customer and partner deployments. Also, from a partner's perspective, we have partners to support these things, to help you and our customers build effective cloud solutions. So, doing all of this to build optimized workloads, these are all shared responsibilities. Building well-architected workloads is a shared responsibility. Microsoft enables it with proper capabilities and features in our Azure platform, but the customer has to build leveraging those capabilities correctly. So in that sense, what goes on in the scope of well-architected assessments? The first thing is the customer application itself, built on the Azure platform. The customer brings a deep understanding of the goals, constraints, and requirements, as well as the knowledge that are specific to their industry. And these are important in a well-architected assessment. Next comes the platform features that the customer use. So we have to ensure that the use of these are in a secure, reliable, operational, efficient, and performant manner. Now, let me repeat this again. Microsoft Azure well-architected framework enables cloud solution success. It has architecture guidance and best practices created for architects, developers, and solution owners to improve the quality of their workloads based on 5 aligned and connected pillars. The first pillar, cost optimization, is about designing cost-effective workloads aligned with business objectives or ROI while maintaining a budget. Operational excellence is about designing reliable, predictable, and automated deployments with monitoring, performance management, and extensive automated and manual testing from an infra and application perspective. Performance efficiency is about lower maintenance costs, improving user experience, and increasing agility by architecting solutions with scalability baked in. So PaaS features pretty much as a default here and always leverage built-in scaling functionality. For reliability, we are talking about scaling out instead of scaling up with expensive hardware. Build reliability across deployments with resilient HA applications and failure mode analysis. Security, built with security by design. Improve confidentiality, integrity, and availability. Provide assurances against deliberate attacks and abuse of your valuable data and systems. Okay, here's another aspect of well-architected framework, right? Among the 5 pillars, sometimes you have to make trade-offs. Some pillars may be higher prioritized than some other pillars for certain contexts. Let's take a look at some of these contexts, starting with dev and test workloads. So for dev and test, sometimes costs can be reduced and optimized, but this may impact reliability. So these are some of the kind of like trade-offs that you may be forced to make if it is in line with business expectations. For mission critical workloads, it may come at an expense of the cost pillar. The cost may increase, but improving the performance of this pillar is mission critical. So that's how you adjust the levers. For securing all workloads, this may be necessary. So you need to make the necessary investment in security when you have a surge in cyber attacks, for example. So you need to protect your most valuable asset. Yep, it does come with trade-offs. So the 5 pillars, one thing to take away is that you need to be aware of the trade-offs that you need to make across these pillars. Now, we talked about best practices earlier, right? So let's deep dive further into specific best practices that we can use to drive workload quality. For cost optimization, please use Azure Hybrid Benefit if it's applicable to you. Use reserve instances, shut down VMs that are not necessary, resize VMs or any other compute resources to the right size. And the best thing is leverage PaaS, always if possible. For operational excellence, number 1 rule, start with DevOps. Make sure that you have a deployment pipeline in place that's automated as much as possible. Always monitor what's going on in your entire workload. Monitor for processes and have regular cadence to review the whole operational landscape. For performance efficiency, always design to scale and always monitor that performance. For reliability, you'll need to define your reliability requirements, test with simulations and force failovers, deploy consistently, monitor health, and respond to failure and disasters. For security, always focus on IAM. Make sure that your IAM is configured properly and always review. Make sure that your infrastructure is protected and give deep thoughts to app security. Let's dive deeper into the security pillar. There is a quip going on for a long time around my team here at Microsoft that security always comes first. Indeed, it is a very important pillar to establish early on in any organization. The objectives of the well-architected framework to create business value by preserving customer trust and avoiding reputational damage. We mentioned of this earlier. So that is closely related to this pillar. From an application perspective, what we will focus on today is DevSecOps. In fact, DevSecOps can impact all of these areas we see here. Right, let's start with an urgent call. Folks, enterprise can no longer wait to address security. It only takes 3 days for a hacker to exploit a vulnerability, leaving security teams little room for errors in their response. Attackers now shift left and compromise upstream dependencies and engineering systems. The result is that these attacks can impact entire development environment and software supply chains. With this threat landscape that is changing, we have already seen two examples of modern attack vectors, Codecov and Electronic Arts. In Codecov's case, an attacker targeted their developer workflow and software supply chain. The attacker was not only able to gain access to their Google Cloud storage account, but also to upload a new image into thousands of builds that scan their software supply chain, extracting even more secrets and widening the breach. Another example is EA. EA recently had source code from one of their games stolen due to stolen cookies that contain Slack login information. They didn't have the secret or identity protections needed, and these vulnerabilities became an easy target. There's also a recent supply chain security example known as the Log4j vulnerability. This has impacted more than 35,000 Java artifacts. The vulnerability, which comes from a popular logging tool in the biggest Java library, the Maven Central Repository, allows an attacker to perform remote code execution by exploiting the insecure JNDI lookups exposed by the logging library Log4j. This exploitable feature was enabled by default in many versions of the library, and this allowed the attack to spread to many affected parties all at once. Well, this is not just an issue for enterprises. The US government has also taken notice of the new threat vectors targeting federal networks and data centers. The Biden administration recently signed an executive order to place more stringent requirements on public sector entities to ensure the US is more prepared for the next age of cybersecurity. Just like GDPR, these guidelines from the President's Office dictate rules for vendors securing and implementing their software throughout the nation. To safeguard the developer cloud against these new threat types, the answer is to shift security left and leverage cloud-native security. Shifting left helps enterprises find and remediate vulnerabilities earlier and across their development lifecycle. Enterprises that extend security to development reduce security incidents by 80%. And it's not just a reduction in events, there is also a financial component. It costs 60 times more to fix a security defect in production than in development. Blending security and development together within the development workflow remains a challenge for many enterprises. While more enterprises are starting their transforms, there are 62% of enterprises that have yet to integrate security into the development phase. Now, how do we start shifting security left and moving to cloud-native environments? First, it's important to understand the differences between adopting DevOps and DevSecOps. You may be familiar with how DevOps and collaboration between developer and operations led to faster software delivery. DevOps combines people, processes, and technology to deliver continuous value to users. DevSecOps is the evolution of DevOps, where the company takes a security-first mindset, putting security into every phase of the development lifecycle, from design to delivery. When implemented successfully, companies gain both the speed of DevOps and the holistic security and peace of mind that comes with DevSecOps. In the sprint towards digital transformation, DevOps had been adopted at a much higher rate than DevSecOps. And here's why. DevOps directly impacts a developer's ability to deliver, which, as a result, impacts an organization's ability to deliver value to customers. And organizations are quick to evolve in a way that allows them to code, collaborate, and ship faster and more efficiently to deliver continuous value to their users. DevOps also provides developers with a lot of positives. Developers are saving time and shipping more code faster. The code is of a much higher caliber, and it leads to continuous workflow improvements and work satisfaction. However, organizations that adopt DevSecOps unlock the ability to ship code at the same speed securely. Specifically, DevSecOps help organizations shift security left to occur at more critical points throughout the development lifecycle. It also helps organizations to form a seamless workflow by integrating into existing tool chains. More so, this aids organizations to continually identify new threat vectors. DevSecOps presents barriers and inefficiencies for developers that we don't find with DevOps. These include organization and team gaps. Some organizations have security-specific teams who own all of security. This silos DevOps and SecOps and leads to fragmented security culture. Secondly, skill and knowledge gaps. When DevOps and Dev teams don't see security as part of their responsibility, the skill base solely stays within the SecOps team. Third, solutions are not being built for developers, leading to issues like false positives. False positives are high because the tools live with security teams rather than developers. Since security teams are more likely to scan repos than developers, they may only run them once a quarter, causing them to be higher than the rate would be if this tool lives with developers. Another issue is that we also see misaligned expectations. In DevOps, having a 30% failure rate on unit tests is considered very bad. However, in security, having a 30% failure rate is actually good. While we are always dealing with a trade-off between false positive and false negatives, security prefers no false negatives and more false positives. However, a developer doesn't want any false positive and doesn't care as much about false negatives. Even with these benefits, DevSecOps adoption is slower, and part of that is due to required organizational changes. It's also due to knowledge gaps that must be filled in order to safeguard the developer cloud. There are different key criteria for success for developers and CISOs. Development teams are all about speed and productivity. Generally, their teams have three main requirements. The first is to ensure developer velocity is maximized, so there are no limits to innovation and speed. The second is to not put any increased complexity on the developer. How? Through developer-first tooling that's secure by design. And third, to involve developers in security conversation and empower them to contribute. And for CISOs, it's more about protecting company IP, data, and secrets without impeding the development process. Their top three requirements reflect this difference. The first is to augment security practices with cutting-edge forensic and detection tools. Another is visibility across applications, from testing to production. And this requires partnering with developer teams to gain holistic observability. And last, it is the ability to proactively hunt threats instead of operating in a state of reactive security. Fortunately, DevSecOps finds commonalities for both developers and CISOs at an organizational level. First, we find shared accountability through adopting security as a company-wide culture and tracking the right metrics. We also find it from securing the development environment to limit developer machines, infrastructure, and code bases as attack vectors. And lastly, it's about seamlessly integrating security in the developer workflow to involve developers in security processes in a non-intrusive way. First, let's talk about shared accountability. To make DevSecOps successful, it's crucial to break down silos between DevOps and SecOps and provide alignment between their KPIs. As we think about shifting from centralized security teams to including developers as accountable, we need to shift from having a centralized security team to a culture of security as a shared responsibility. Let's start by aligning on the metrics to measure. It's important to focus on measuring only the most critical and impactful KPIs. Historically, developers have tracked deployment and shipping speeds associated with pipeline throughput. Now, along with pipeline throughput, it's important to focus on metrics that deal with life site health. Generally, the most critical metrics to track are time to detect, time to communicate, and time to mitigate. Focusing on these three metrics allow your organization to lower the time to respond to vulnerabilities within that crucial 3-day window. Next, let's discuss securing the development environment. Securing the development environment begins with securing all cloud-based developer machines. That means we need to place strict controls on how developers interact with their environments. For code browsing, we should limit scope for non-trusted repositories to a browser sandbox. We also should only build non-trusted repositories in an isolated environment, not on a local developer machine. And identity policy management is important too. Clone repositories should implement least privilege access principles. When implemented correctly, you are defending your organization against common attacks. Let's have a look at Codespaces. This is the sample app that I forked from Azure Samples that I will use for this session. The reason we fork the code is to make changes further down the road. With that, we can now start our Codespaces. So we'll create a Codespace based on the main branch of this repository. And you'll take a little bit of time, not too long. Okay, it indicates that the image had been found and the container to run the development environment had been built. Okay, now that's the Codespaces started. Remember earlier I mentioned that we will need to modify the code more. So here I'm noticing that there is no dev container definition. So dev container.json allows us to be more precise with the kind of development environment that we want. So here I'm noticing that we do not have Docker extension or Azure Container Apps extension installed. So let's go about getting that into our dev container. So we start by looking for Docker. So instead of installing it like this, what we want to do is right click and add it to our dev container. So by having this dev container, it will not just benefit us, it will benefit other developers as well, as they will definitely need to have these kind of extensions working at their code space as well. So here there's no container configuration currently found, so I'll add one. And let's add one that's based on Node.js. Let's do for the default one. And we'll need Docker as well. So let's go for Docker from Docker. Let's reuse the host Docker engine. And we'll look for, go for the latest one. And there we go. We have a dev container.json now. Let's look here. Right, cool. Within the dev container.json definition, we will now see that the Docker extension had been added to the list of extensions. These are the extensions that will be automatically added when we turn on our code space the next time. And we have Docker from Docker as a feature as well. Now let's commit our code and see how it can benefit the next developer. So let's add to Git and commit and push. Okay, so let's have a look at how the next developer can then see this extension already added when they turn on a new code spaces based on this repository. Let's go to the repo over here. Okay, so let's turn on a new code space. So notice that there's already two code space. So I'm going to create a new one. So again, it's going to build the container again. Okay, let's view logs just to see. So you notice it takes a little bit longer. It's setting up the necessary Docker, and okay, now it's done. Yeah, container started. Okay, now it's saying that Docker from Docker is not a V2 feature. Okay. Okay, so now this is a new code spaces, but it's actually turned on based on our newer code with dev container added. So this is the dev container file, right? So let's see if we have our magic here, which is the Docker extension installed. Yay! So yeah, so the next developer, imagine, will then save a step by having this extension already there. Remember seeing the notification on Docker from Docker earlier while turning on the code space? Right, let's find out what's that about. We can do that with the creation log, and we can access it from the command palette. Let's go to creation log. Yeah, so this is the creation log, and let's head to Docker from Docker. Yeah, so let's get a detailed view. So feature Docker from Docker is not a V2 feature, attempting fallback to V1. Yeah, that's fine for our purposes. Okay, now the next thing we should do is to build our application. Let's look for our Docker file, which is the source Docker file, which is this one. Okay, then we build a image in our dev environment here. So yeah, that is fine. Probably a little bit of a wait here. Let's load this up. Okay, that's fast enough. Now we can turn on our containers. Let's bring up the Docker extension. Yep, and this is the image. Let's run. And we have our container. Now let's have a look at our API. Let's open it in browser. Yeah, as you can see, Visual Studio Code will set up the port forwarding as well, and the authentication as well if you run it through Visual Studio Code. And there you have it, our API. Now, you also need to secure your cloud environments. In order to ensure that your development security is aligned with your developer velocity, make sure you implement a centrally governed and secure engineering system. Also, you need to make sure that you allow only trusted, approved, and authorized DevOps pipelines and actors the ability to enforce supply chain controls. Lastly, you need to control deployment from non-trusted pipelines. Right, all of this will fortify your organization against threats such as build tampering and unauthorized access to package repository and production infrastructure. Now, DevOps pipelines are another important consideration when securing the development environment. To ensure your organization is producing verifiable and reproducible builds, you'll need to adjust security at every point, from compilers to build machines. Let's take a look at each step in more detail. For compilers, make sure that each compiler signs properly with validated signatures. For the build itself, make sure there are verifiable build manifests that describes sources, cryptographic hashes of binaries or artifacts, and full build parameters. With the build machines and infrastructure, you need to make sure that these are highly restricted with least privilege access applied and with ephemeral build agents. With DevOps services, you need to make sure that the build and release infra uses isolated managed identities and sensitive tenant profiles are isolated. With compilers and user processes, you'll need to ensure that execution is done in isolation or in lockdown environments. For the software on built machines, make sure that all are signed properly with validated signatures. So practices like this ensure that your organization is secure from threats like compromised compilers and build machines and compromised dependencies. In order to harden DevOps infrastructure, you also need to harden access to code bases. The general rule of thumb is that everything should have a maintainer. You should follow least privilege access. Grant access to developers by organization. No global access. You should limit elevated privileges. Do so only when absolutely necessary and implement a finite duration on each access levels. Changes to identity controls like this help secure your organization against attack like source code exfiltration on developer machines and source code tampering or injection of malicious code. In order to ensure the code to cloud pipeline is secure, organizations need to do the following. Create Azure AD and device policies that will secure development machines. For example, if a device gets lost, wipe the device. Next, make sure all operations adhere to least privilege principles. Next, regularly scan for identity access management to ensure least privilege access management policies are adhered to. Also, use multi-factor authentication and dual key or just-in-time approval for privileged operations and human-induced pushes. Next, enable endpoint protection for all workstations and allow only registered devices. Lastly, inject identity early into the automation pipeline. Fortifying identity controls like this helps protect against attacks like compromised credentials and malicious insiders. Your organization should automatically detect and respond to suspicious activities. Here's a few things that your organization can do. First, ensure that you are monitoring for anomalous activities to identify and detect activities that are nefarious, from mass repo cloning to downloading or deletion. Make sure that you enable alerts and routing for security policies across DevOps pipelines. Make sure that there are regular scanning for IAM to ensure that least privilege access management policies are followed. Lastly, make sure that notifications of leaked secrets, tokens, or credentials to developers are automated. Enabling holistic monitoring can help protect your organizations from threats from within and escalations of brute force attack or intrusion access. Now, let's take a look at the cost optimization pillar. These are some of the topics in this pillar, but with regards to applications, the PaaS topic is very interesting. Look for areas in the architecture where it may be natural to incorporate platform as a service options. So these options include things like caching, queues, and data storage. Anyway, PaaS reduces time and the cost of managing servers, storage, networking, and other apps infrastructure. Now, in terms of platform as a service, there's various Azure services out there that's available to you. So for example, instead of running your own Active Directory, you can consider using Azure Active Directory. Instead of running Elasticsearch, there's Azure Cognitive Search. Hadoop, there's HD Insight. For IIS, you should definitely look at Azure App Service. For MongoDB, there's Cosmos DB. For Redis, there's Azure Cache for Redis. For SQL Server, there's SQL Database. And for file share, there's Azure NetApp Files. From an application hosting perspective, the choice of IaaS versus PaaS, and even between the various PaaS, that's always something that you need to navigate carefully. Now, let's take an example from a containerized application point of view. We'll first go through the portfolio of Azure services available to you. So AKS and Azure Red Hat OpenShift, those provide full access to the Kubernetes layer, right? So the cluster in itself, you can control the ingress, you can control networking, you can control maintenance and scale. On the right hand side, you have Azure Container Instances. So it's a way to launch container with hypervisor isolation. So container as a unit in itself in Azure. In that sense, it's a low-level compute, kind of like your VM, and also kind of like the local container runtime called Docker Desktop, right? So it's useful in some ways, and one of the ways is as virtual nodes as part of Azure Kubernetes Service, right? So here in the middle, the new thing is where things become really, really interesting. So Azure Container Apps, right? So this is something that we truly want to consider for our application. So if you look at the application that we just brought up on GitHub Codespaces, right? It's a microservice application. So what is Azure Container Apps? Azure Container Apps operates on top of the Kubernetes cluster. Okay, so it's on top of the Kubernetes cluster, but it's entirely managed. The whole cluster is managed, so you don't have to worry about the managing the cluster yourself, right? So it's actually very interesting for those that are focused on application delivery, right? And you want to focus on really iterating on your features and all of that, right? And not on maintaining clusters, right? So the scaling, the HTTP routing, and service discovery, all those are still there for you in Azure Container Apps. So yeah, it's a very interesting service. We'll deep dive on it very shortly. But let's now take a look at the bottom right, right? So we have Azure App Service and Azure Functions. Azure App Service, it's a way to host web apps and web APIs. You can publish code directly to it, and you don't have to manage a container. And it has cool features like deployment slots and all that, right? But if you compare Azure App Service to Azure Container Apps, right? Azure Container Apps is actually more optimized for microservice that needs to communicate to each other, right? So Azure Container Apps is more suitable if you are looking at developing microservices. Lastly, we also have Azure Functions, right? Okay, so Azure Functions is serverless. Um, the thing about Azure Functions is that you need to interface with it with Functions SDK, right? So it's a little bit more opinionated. But on the other hand, Azure Container Apps allows for any containerized app, right, to execute while still being triggered by the same model, the serverless model, using events, right? So yeah, there you go. That's all the overview of the Azure Containers portfolio, right? With respect to this portfolio of options, the two axes here are very useful. The well-architected framework recommends use of PaaS as much as possible. To that end, in the x-axis, the more to the right it is, the more managed it is as a PaaS. The platform handles more, and you focus more on application development. Nevertheless, there are times where your application may call for more fine-grained control. From a y-axis perspective, it is all about how opinionated the platform are and whether your application can fit the opinionated approach of the service, and also which part of your application portfolio is suitable for which platform service. Today, we have reviewed how we create business value with well-architected workloads. We have gone through what the various aspects of well-architected that are available from an application perspective. We have taken a look at the pillars and even deep dive into some of these pillars. If there's one key takeaway that you can bring with you today, it is this. It is that Microsoft Azure and GitHub Application Innovation Services can often help remediate and strengthen many of the points across the pillars of a well-architected cloud environment. For example, DevSecOps with GitHub enables best practices across security, reliability, and operational excellence. Azure App Service enables best practices across all pillars, and so on and so forth. Now, your turn to make the best of well-architected framework.